Okay. Good morning, everyone. My name is Gayatri Bharadwaj. I'm the SWAN APAC manager, and I welcome you all to the Smart Sewer webinar today, hosted by our risk ambassadors, facilitated by our risk ambassador Rajeshwari and John Bresford. And a big shout out to them because they are facilitating this call. So this call is recorded for quality purpose and for resharing the recap. And also the AI tool is joining this call, just to give you a heads up on that. I'll be sharing the screen, and Rajeshwari and John will be facilitating this call. So I'm just going to start sharing and start the call. Okay, over to you, Rajeshwari.
Good morning, everyone. This presentation is about innovating smart sewer systems in Australia, and we have two guest speakers from Southeast Waters and Kallipr. Yep, next slide, please.
Easy. So like Raj says, we've got Juan today from Southeast Water, so he's the product development team lead over there. He'll be running us through the first of the two presentations. We've also got Stelios, who's Chief Commercial Officer at Kallipr. He'll be the second of the two conversations. After which, we're going to have a little question and answer session at the end. So if you do have any questions, just pop them in the chat during each of the sessions, and we'll run through them all at the end. And then I think Gayatri is going to run us through a short SWAN update towards the end of the webinar call. Just quickly, forgot to introduce myself. As Gayatri said, John Brailsford. I'm head of sales at Optimatics, which is also part of the Suez Digital Solutions Group. And then I also lead our Rising Smart Water Professional cohort here in Australia and New Zealand. So, yeah. I think if you, Raj, do you want to introduce yourself quickly as well? Yeah.
Yep, next slide, please. Hi, everyone. My name is Rajeshwari, and I've been involved with SWAN for the last year, and I'm working as a Rising Smart Water Professional Ambassador. And I work in Southeast Waters as a product development test engineer, and my role majorly is involved with validating various IoT devices that go in Southeast Water network. And smart sewers is a specific topic that is quite involved in, as well as we're trialing a lot of devices and working with the existing smart sewer systems that we have at Southeast Waters. So I want to give a quick introduction on what smart sewer system is and what are the benefits. Smart sewer system is basically any sensors or any sort of algorithms and data analysis that we do from the output that we get from the sensors, and various technologies that are involved in the network. That could be mechanical devices like float switches that allow us to detect any anomalies in the system, any blockages that could be developing, and give us a indication of flooding or prevent any pollution events. And having the smart sewer systems is a big step change from going from a reactive response to a proactive mitigation of operational decision support. So it helps us make sure that we are aware before any event actually happens on the field. And the various advantages of the smart sewer systems: one, it gives us a real-time monitoring system, because how the manholes are designed, it's very hard to know what's really happening in them. And having some sort of a sensor or a device there gives us a real-time monitoring, making us make sure we are always aware of where something could go wrong before it even starts happening. And helps prevent various sewers and spills and flood prevention. And it has a lot of environmental protection, as making sure the water does not get contaminated due to sewer spills, especially in locations where it's close to any lakes or rivers or oceans. It always prevents that we don't pollute anything. And it's also cost saving, and it has improved maintenance. So this is a very, very future topic that is still a lot of development that's going on, and we wanted to present this so that we bring in the knowledge that we have from our APAC team to talk about what they've been working on this systems. Next slide, please. So today's presenters, we have Juan Londono from Southeast Waters, and he's working as a product development team leader for past 5 years. And he's looked after the introduction of IoT devices into the production network. He's experienced in development, rollout of various IoT devices, and he and his team play a key role in managing and integrating smart devices and solutions for Southeast waters. And the second speaker we have is Stelios from Kallipr. And Stelios is Kallipr's Chief Commercial Officer, responsible for sales, solutions, and scaling new products and services for Kallipr. And Stelios has extensive experience in deploying smart sewer level monitoring solutions, working closely with various utilities globally. And I'll hand over the presentation to Juan Londono, please. Thank you.
Do you want to start sharing your screen, Juan, or do you want me to continue?
Yeah, I'm
I'll stop
going
sharing.
to take over and
Thank you.
share my screen. Let me know, please, when you see it. Can you see that now?
Yep.
Yeah, awesome. So my name is Juan Londono. I'm the product development team leader for operational technology in Southeast Water. I've been working with Southeast Water for 9 years now, but the last 5 I've been heavily involved in the evaluation, verification, and rollout of IoT devices within the network, and also heavily involved on the development of smart sewer technologies for Southeast Water. So I'm going to take you today first start with an acknowledgement of country, then very briefly introduce about Southeast Water, what we do, how big or small we are, etc. Then I'll run you through the history of the blockade device. The blockade device was a device we developed internally at Southeast Water to address surcharging manholes in the sewage. Then a little briefing on the learnings that we had from that rollout and the operation of the blockades, and then quickly run you through the most recent trials of manhole devices we've done on the last year and a half. So I'll start with the acknowledgement of country. Sorry, I'll go back. Southeast Water proudly acknowledges the traditional owners of the land on which we work and live, and pay respect to their elders past and present, and we acknowledge all Aboriginal and Torres Strait Islander people and their continuing connection to the land and waters throughout Australia, and we recognize and value the rich cultural heritage and ongoing contributions of our Aboriginal people and communities. So about Southeast Water. We support healthy and livable communities by delivering water and sewage and recycled water to about 1.8 million peoples. Part of that is each year we are delivering 138 billion liters of drinking water, managing 152 billion liters of wastewater, and delivering 5.9 billion liters of recycled water for residents, businesses, and agricultures. We also do biosolid recycling for soil improvement and generate renewable energy from biogas and solar. We own and operate around $5.2 billion assets, including water, recycled water, and sewage networks, and manage over 27,000 kilometers of pipeline. Our service area is covering more than 270 kilometers of coastline within the Port Phillip Bay and the Western Port Bay. And the land, we're covering 3,640 square kilometers from Port Melbourne to Portsea, and approximately 30 kilometers east of Pakenham. So it's a pretty big catchment area that we manage. And then from our vision, or core vision, is we innovate with purpose and act with care. And this is the main driver for everything we do at Southeast Water. And our purpose is to deliver healthy water for life for our customers, community, and environment. And we have 5 focus areas within the organization. We try to empower people, deliver for our customers, protect our environment, optimize our operations, and drive innovation at scale. And these 4 focus areas are always part of how we take things on the operations day-to-day basis, and how we try to innovate to optimize our operations. And our core values, first and foremost, we put safety first on everything we do. We're bold, we care, we discover, we're real, and we deliver sustainably. So that's Southeast Water. Then the history of the blockade. The blockade pretty much looks like this, and it's effectively a manhole level, sewer level monitor. Um, the history of it, it goes back all the way to 2013. In 2013, we developed the first original blockade, and this is as simple as a float switch connected to a 3G modem. So when the float switch trigger, we will get an alarm to the SCADA operation center and know that something is surcharging on a manhole. That proof of concept gave us the reasons for building a larger business case and start doing the development of the blockade version 2, where we included a little bit more of engineering into the solution, and we use an ultrasonic sensor and a similar 3G modem to get the report data, the data reported back into the SCADA server. Again, this is slightly more complex because we're no longer getting an on-off alarm. We're actually having trends on the sewer level, so we get to get more information on the operations of the sewer network. Then on 2018, there was the introduction of the Environmental Protection Amendment Act, and more specifically, this act introduced the general environmental duty. That was the extra push we needed to say, okay, we really need to invest in getting a sewer level monitoring device out there so we can monitor and prevent spills before they happen. That led to the development of the advanced blockade. The advanced blockade was pretty much the version 3 of the blockade. We were using a similar ultrasonic sensor with range up to 5 meters, using no longer a 3G modem, but now we're entering into the NB-IoT modems and the CADM1 model. And we added H2S, an H2S sensor in the unit so we can monitor H2S levels on the manhole. And then we also added flow measurement capabilities within the device by measuring the slight differences between the level of the sewer flowing. After we finished the development of the advanced blockade by the end of 2018, we started deploying these units, and by 2021, we had 875 advanced blockades deployed in the network. But even though the number is big, we were only covering 5% of the sewer network that we operate. And in the 24 months up to 2021, with 875 advanced blockade deployed, we detected over 100 sewer blockages that otherwise would have been spills. Then by 2023, we installed 2,000 advanced blockade, and we were covering now 10% of the sewer network. And in the previous 12 months before 2023, we detected an estimate of 183 sewer blockages. That's a brief history of what was the advanced blockade and the results we were getting from that. So if I were to summarize the results from that development, I'll split them into positives and negatives. The positive side of it is we definitely saw a reduction on these spills in the monitored area. So the initial 875 blockades were deployed in very specific areas that were highlighted as the most problematic areas for sewer spills, where a sewer spill will cause the most damage to the environment. So we focus on those ones, and we saw a typical reduction of 50% within the first 2 years of installations of the device. Then the total number of spills in the overall network got reduced, which is great for the operation. And the increase of blockages corrected by month obviously got increased versus the ones that were only reported by customers before the installation of the device. And it only makes sense that that had happened because we were monitoring more actively what was happening on the network and detecting the blockages before they become spills. And we saw a reduction on the cost of related spill incidents because we were detecting them before they were actually becoming a spill and generating more damage. The action that we were taking before that was way less costly than if we were to be a remediate action after the spill. Then the negative side is the installation cost of the devices. The blockade, the advanced blockade in particular, was a very complex device, and we needed very well-trained personnel to install it to ensure that the device will operate correctly. Obviously, that will be reflected into an installation cost. Then the device reliability. We realized that we will have to have constant maintenance on these devices, and then the maintenance cost increase, which will be reflected within the operational cost of the company. And then the cost and the disruption caused by false alarms. So some of the devices were not behaving the way we expected it and reporting false alarms. And these obviously, because we are monitoring from remotely, we couldn't tell if it was a false or real alarm, so we still needed to deploy crews to the alarm site. And obviously, being a false alarm, that would be an extra cost that we didn't want to incur on. And the other thing is the associated cost with having an intrinsic safety certified device and maintain that compliance. This definitely was a very costly exercise for us as a water corporation to maintain on the device. So what we learned from the blockade and which one of those learnings can we carry on for the next stage? There's too many things that we've learned from it, but I'll try to summarize it in this slide. The first one, and it seems an obvious one, but I'll put it out there still. Sewer is a very difficult environment for electronics to operate reliably. So there's a lot of engineering on making sure that they operate reliably. It's a very, very harsh environment to operate in. There is a lot of humidity considerations. Condensation and corrosion were probably the top two of issues that we had to deal with on the device's day-to-day operation. But there's also temperature changes and the effect on material expansion and contraction. So if you mix those three things together, it makes it really difficult for a device to operate in that environment. Then it's also the likelihood of the explosive toxic gases in the operational environment, which make it very important to have that intrinsic safety certification. Then it's also learnings around the enclosure design. So how the device should look, how the enclosure on the device should look. First one is the enclosure should ensure that the device survives a full immersion in sewer. So it's not just water, it's actually sewer. And if after a surcharge, you will get all sort of things tangling into the device. So we need to make sure that the device can be easily cleaned with a water jet. So the way the maintenance crew are going to maintain the devices is just going to pop the manhole lid and just water jet the device to clean everything that is being hanging on it. Then maintaining to a minimum the enclosure parts. It's just keep it lean. The more parts you have on the enclosure, the more failure points you'll have. So keep it clean, keep it simple. And a simple but effective humidity seal. Again, getting less parts on the device is reducing the likelihood of something going wrong. Maintaining the humidity seal in an enclosure is pretty complicated, especially if you consider the temperature changes and the effects on material expansion and contraction. We learned that the replaceable battery is actually an advantage. We had to have a lot of these blockade devices. A lot of the calls were just to replace batteries, and that definitely expanded the operational life of the devices and obviously reducing the cost. The other thing is the length of the device is pretty important on shallow manholes. So the longer your device is, the wider your blind band will be on monitoring of the manhole. If you have a manhole that is 2 meters deep and you have a device that is 50 centimeters long, your operational range just got reduced by a quarter just by the length of your device. The other thing is the beam angle selection that applies both for radar and ultrasonics. It's very important when you're considering operate in narrow or deep installations because you'll have a lot of reflections if you have a wider angle, beam angle. The other thing to consider is what protocols are your devices using. These will have a direct impact on the battery life of the device. If you have a very chatty protocol, your device will suffer that and you will have a bigger, larger battery to back that up and having probably the same operational life of a device that it's using a protocol that is less chatty. The dual alarm level and the dual reporting frequency, it's definitely something we want. So we don't want to keep monitoring the devices at a high frequency when they're in the regular operational range, but definitely once they surpass at an alarm threshold, we want to have that reporting more constantly. Then the physical installation, the bracket where you install the device, it should be removable without tools. Maintenance needs access to the manhole and they don't carry all specialized tools to remove these things. It should be flexible, so we could accommodate the bracket for optimal positioning, for optimal measurement, and again, keep the number of parts to a minimum, so you're reducing failure points. And then material considerations. In our personal experience, nothing but stainless steel 316 survives manholes. Everything else will corrode very, very quickly. And we need tethering. The tethering is very important for the units. If something goes wrong, we don't want the units to just fall into the sewer and generate a bigger problem. And commissioning tools and processes, it has to be simple. Cable connectors are prone to humidity ingress, so try and avoid any sort of cable connection required for commissioning. We will prefer wireless local connections and immediate reading feedback while installing. It's definitely a good thing to have because it will make installation much more reliable. And it has to be simple because the simpler it is, the less specialized the crew that you have to put out there to install these devices, your cost will be going down for that. And then device reliability, it affects your maintenance cost. Data persistence, how are we ensuring that the device maintains the data if the connection is lost with your telco or whatever other connection you're using. And remote configuration is a must. Once you're thinking of managing thousands of devices out there, you don't really want to rock up to each one of the sites to do a configuration change. You have to be able to do that remotely. And the sensing technology needs to differentiate from static obstructions like landing pads or ladder steps, etc., versus moving objects like the water body of water flowing on the bottom of the chase. So what we've trialed recently, why are we doing this? Because the blockade is end of life. We internally decided we are not investing anymore into developing the blockade or building any more of these. How are we going to then replace the units that fail? And how are we going to maintain that state of knowledge that it's required as part of the general environmental duty? So then what do we need from the devices that we want to put out there? We want them at this stage to directly report to SCADA with minimum hoops, so the operational teams have a reliable connection and data availability. We need to maintain a low operational cost. We want to use NB-IoT communications. That's our preference at the moment. We need the devices to have a Zone 2 explosive environment certification and maintain that. and we need to have reliable reads of levels of at least 5 meters. This is coming from the spread of the length of manholes we have on the network. And if we cover 5 meters, we're covering something like 93% of our manholes. And we want to have a minimal deadband on installation. So again, referring to the physical size of the device. And we need them to be installed without confined space entry requirements. So they must be installed from the ground level on the manhole opening. And there's a few more, but these are the core ones. What have we tested so far? Because of the state of knowledge, we are installing these units in a manhole that is adjacent to a current blockade, or in the same manhole that a current blockade. That plays double whammy, that we can also have the data from the blockade to compare with the data of the new devices and make sure that they're actually reporting what we need them to report. But it affects from the perspective that the new device is not likely to be suited, not likely to be installed in the perfect spot to get the best reading. So we need to be aware of those things. We've installed 30 high-low level sensors, and out of those 30, we have 3 reporting directly to SCADA. We've installed 20 Metasphere ART sewers, and they're all reporting to the Canvas platform from Metasphere. And we've installed 2 units from Kallipr that are reporting to the Kallipr cloud server. And we are soon going to install another 2 more units that will report directly to SCADA. And this is just sharing some of the installation pictures for the different devices. So these are the Metasphere ART sewer devices we have on the one on the left. It's just installed next to the blockade. The middle one is also installed next to a blockade, but because of the length of the manhole, we had to hang the device into an extension cable. Then the high-low level sensors, again installed next to a blockade on its own on the picture on the right side. And finally, the 2 installed units of Kallipr. Then what is the future for Southeast Water on the smart sewer journey? There is a smart sewer strategy that is happening at the moment at Southeast Water, and this strategy is being developed right now. And it will include more manhole devices being selected and deployed, and it will implement a scalable architecture on how are we going to manage thousands of devices. That's another big piece of work, because it's not only about the device, but how do you manage that data, how you make sure that the data is digested correctly and you get all the information that you really want from it. And we will explore alternative strategies to optimize the sewer network operation. So we are aware that it's not only about monitoring manhole surcharges. There is some other things like preventive maintenance and cleaning that will have a really good effect on how we manage the sewer network. And the message is this: for Southeast Water, this is just the beginning of the smart sewer journey, and there's still a lot of things that we need to work on develop. And that's me. So I'll probably pass it to Stelios.
Excellent, thanks, Juan. I'll just get a screen share going.
We're just going to hold off for questions till the end, guys. I know there's a few in the chat. We'll do it after Stelios' presentation.
Great. Can everyone hear me okay and see that screen share? Or has it not come through yet? Yep, it's coming through. Is that good, John?
Yeah, all good.
Excellent.
All good.
All right. Well, thanks, Juan, for kicking us off. I think after that presentation, I don't think I could have too much more to add, given the level of depth of insight across all aspects of the sewer journey. But I'll be hoping to add a little bit more to end the session. So today I'm just going to be building on what Juan said around some of the considerations for utilities looking to deploy smart sewer monitoring solutions, and some of those the considerations that need to be taken forward. I think probably the first one, as we've heard through Juan's feedback, is the solutions need to be designed to perform in the real world. They've got to be able to withstand some of the real challenges that exist of operating in a sewer. I think, as we've heard from Juan, they're very, very dangerous, highly corrosive, and interesting environments. The way I put it is everything in a sewer seems to want to kill electronics. So it does take a lot of considerations. The first kind of key call out is a saying that we use internally at Kallipr, but it's survive the use case, not the court case. And so what we mean by that is that you need to ensure that when you're deploying a solution, you have adequate wiggle room between the specifications of your hardware and the specifications of the use case and what the hardware can withstand. So a good example of that is, a very common standard is IP68 for water ingress protection. A lot of devices are IP68 as standard, and when we look at sewer monitoring, a lot of the specifications that utilities put out is just IP68. However, when you dig into the IP68 standard, it's effectively only defined as water submersion up to 1.5 meters for 30 minutes as standard, and then leaves it to the vendor to define more after that. If we think of a sewer, devices are definitely going to be submerged for longer than that. So it's important. That's just one aspect of being really clear and defining what the standards are for your smart sewer, and ensuring that any sort of electronics or solution that goes into that sewer can meet it. The second one is signal performance. So this is probably when you speak to any utility globally, whether it's in North America, Europe, the GCC, Asia, Australia, everyone will complain about signal and trying to get a signal outside of that manhole with a metal or concrete cover on top. And so there's lots of considerations there of what network technology do you use, what type of antenna do you use, but it's really critical to ensure that the solution that you choose can transmit signals or can transmit data in really poor signal strength. What we've learned in these environments is that, you're not going to get the greatest signal, so ensuring that whatever technology you choose does accommodate that. But as we've seen in recent years with new network technologies such as narrowband IoT, as well as the use of external antennas, we are able to achieve that. And the final one is just ensuring that the solutions are engineered for environmental threats, whether it's rats, cockroaches, other animals, proximity strikes, high flow scenarios. There's so many things that can occur in that sewer, so many things that we've learned over the years that can cause detriment to the device. So it's really important that they're understood and they're included as specifications when you're looking for these solutions to ensure that they're not impacted. The next one's my favorite one. So as Juan touched on right at the end, but streamlining for installation and maintenance is what's going to give you true long-term value. But also it's going to potentially be the make or break of the business case. One of the first things before considering any sort of smart sewer journey is to really be looking at what is your installation strategy, whether it's how you identify which manholes you're installing at to ensure that the installers are not spending time doing door knocks or trying to find the sites, or even just knowing the process that sits behind the installation, whether it's how the devices are installed, how they're configured, how the installers confirm that everything's correct. We've learned that even if the other parts of the solution are adequately priced, if that installation is not streamlined, it can cause the whole business case to go upside down. And so really having a clear view of installation and how that leads to target average handling times in your business case is key. Maintenance is the next one. So it's all well and good to install a great solution and for it to be working, but as I've learned, as soon as a cleaner comes along, or someone who needs to maintain the manhole comes along and removes the sensor, the question is how easily is it for them to put back the sensor to ensure it's still working. And so having that plug and play nature to the sensor so that it can be easily removed when cleaning or maintenance needs to occur is critical, because as we know, not all installers are going to have the necessary experience to configure sensors, but probably it lends itself to the next point that maybe you need to be considering how these sensors can have that maintenance level built into them. And then the final one is total cost of ownership and thinking through this. So we've seen a lot of times where there's been a focus on cost, but not looking at the true life cycle cost of the solution. We are starting to see, though, globally now that as utilities put out tenders for smart sewer solutions, they're asking vendors to submit 5, 10, and 15-year life cycle costs. And that's to really understand what is the true cost to operate these solutions over a very long period of time, whether it's replacement devices, replacement batteries, maintenance of the sensors, etc. There was a tender last year, I won't say we're out of Europe, but one of the utilities there asked for a 15-year TCV cash flow view for each vendor's sensors, and that was really to understand how many battery replacements they thought that would be needed, how many device replacements they thought would be needed, and to make sure that they're adequately measuring each of the vendors against that. And the final one is preparing for a digital future and focusing on your data strategy. So I think probably the first and most important one is to ensure that you are focusing on your data strategy and on solutions that can seamlessly integrate either into your data lake or into your end user system. The reason why this is most important is it enables you to have no vendor lock-in and a vendor agnostic system. As soon as you start to break things apart, such as the hardware, the device management, the connectivity, it becomes very difficult to enforce SLAs of who's accountable for what, but it also makes it very difficult to seamlessly integrate different vendors in as your suppliers increase, as well as manage them. The easiest way to manage vendors is with a data-driven SLA. Either the data is available or the data is not available, and we're seeing a lot of that coming through data as a service models, which the SWAN working group has been a leading force in, but it's highly critical to ensure that you can maintain that vendor agnostic ecosystem. Choosing the right tools for the right job is probably the next one, and that touches on the sensor types. So being really clear on what you're trying to measure in your smart sewer business case and how it leads to that. I've spoken to a lot of different utilities. I think some are on the call and talking about how they look at their smart sewer journey, and they definitely see the need for different types of sensors, whether it's a float switch, a radar sensor, an ultrasonic sensor. They see different sensors for different use cases. And some good examples of that is we've got one customer who's got several locations with really low flow of sewer, where they don't necessarily think that a radar continuous sensor is going to provide them with much value. So they're going to continue to deploy float switches there. We've got other customers who are looking to understand inflows, infiltration through their networks, and have bottlenecks into their wastewater treatment plants. And so they're really keen on understanding those continuous levels, and they want to deploy radar sensors. So again, being clear on how you map the sensor to the use case is critical. And final one is automation. So the key thing is looking for vendors who are continuously looking to automate manual processes and or manual steps that exist in maintaining these solutions. As we've touched on, when these things scale to tens of thousands of sensors, every extra minute of time is going to be an extra cost somewhere in the value chain. And so ensuring that things are continuously automated, whether it's onboarding, the sensor maintenance, the configuration of the sensors, even the maintenance, is going to be critical to keeping those costs down and ensuring that the business cases can be achieved. Excellent. That was everything from me, John. Probably open up to the floor now for some questions.
Yeah, awesome. Thank you, Stelios. Yeah, we did have a couple of questions in the chat, mainly focused on the earlier presentation. I think Brad Thompson asked one, but I believe he's actually dropped off the call now, looking at the participants. So Juan, just for you, I guess, and for anyone else who might be interested why the total number of spills reduced across the whole network rather than just the monitored area. So were there any other activities that contributed to blockage reduction?
Top of my head on those first 24 months between 2018 and 2021, the total reduction of blockages across the whole network was something like 2%. So it's not really significant, but if you consider that we were only monitoring 5% of the network, it's actually a really good outcome. I'm not sure if that in that period of time there were some extra factors that affected that number. Mm-hmm. Yeah, I'm not privy to that information, to be honest.
That's fine. And a couple from Kevin as well. Kevin, would you like to ask them yourself, I guess? Hand over to you. if he's allowed to unmute himself.
Technology, just trying to unmute myself.
You're good.
No,
don't worry.
Yeah, obviously, I'm just curious in terms of, obviously there's static monitoring, and I think the goal for most utilities is to get to some sort of dynamic monitoring that would enable to go from reactive to proactive. So obviously trying a lot of different technologies, should we say data setups. I'm just curious what was done really at that kind of development level, and how you see that, getting a higher level of analytics to get ahead of the curve. So that's Southeast Water.
With the blockades deployment, not much. It was honestly very basic. We had a threshold set up on installation for each one of the manholes, and if the level was above that threshold, trigger an alarm. The alarm will be reflected on SCADA, and then the NOC operators will assess the alarm and determine what's the best course of action. So it was very, very simple, but definitely it's part of the conversation on that strategy for smart sewer that it's happening at the moment, is how are we going to use those analytics. But yes, so far we haven't done anything significant on that aspect.
And I assume that kind of answers that for the next question around the sensitivity of an asset to rainfall, groundwater, or other ingressions. Has it been developed or tested against a known, should we say, leg that's got issues with I&I?
Yeah, not that I'm aware of.
No. And I had another one at the tip of my tongue. It will come to me in a second. So as a general strategy for Southeast Water, I mean, is the objective to obviously reduce false positives, but reduce overall alarms to make operational and field activities more efficient? Is that a goal?
It's probably a little bit more than that. So obviously one of the core drivers or focus points that I shared initially is protecting our environment. So that's definitely one big focus for us, is preventing those spills and the environmental effect that they'll have. It's also understanding the network and optimizing the maintenance that we do on the network, so we can assess these blockages before they become spills. And that will also give us an optimization on how we deploy crews, what is the response time we have to get to that site. It's getting more information from the network, getting to know more the network, and at the same time preventing customer complaints because of spills and preventing the environmental impact that they'll have.
Yeah. I don't want to hog the floor, but this one's probably, it's just one other, and I'll let people jump in. But it's more of a political one. Boundaries. Obviously, Victoria's quite interesting in having retail bulk, but the other element to that, and of course, is a factor in spills and pollution events, is stormwater, and the boundaries of who's responsible for what. Have you developed any kind of relationships with councils to kind of mitigate? And this is probably not specific to your smart water activities, but more of a consideration, is if you want to be really successful, how do you pull along some of the councils in their catchments that might be unfortunately getting into your system?
Me being part of more of the product side of the development, I'm not really across that, but definitely something that I'll bring to the conversations on the smart sewer strategy, because it makes a valid point. Yes.
Yeah. Thank you for the answers. Thank you.
Great. Awesome.
No problem.
Thanks, Kevin. Appreciate that. Don't ever apologise for asking too many questions either. It's great. Stelios, I've actually got a question for you. I was going to say, do you have any good examples of like the assets lasting in excess of 15 years? What with it now being like written into tendering documents, or have an approach to make them last 15 years or more?
Look, it's an interesting. I think. Look, probably the lowest common denominator there is always going to be the batteries. I think, especially when you in a lot of the battery modeling we do, the discharge profiles go through the roof after 10 years. So I think the first piece, that's just when we've looked at our solutions, is considering how you handle that, because if you're designing for 15 years, knowing what it just the physics and the chemistry of batteries, you're going to have to consider that. But I think on the hardware, you look, I think there is ways to do that and get to that. I think what will eventually, the way we view it is you'll probably have a percentage that will survive / not survive and getting to the 15 years, and then how you accommodate that. But yeah, sure, like in a lot of our design, we do mean time to failure analysis that ensures that the componentry can get there. And then I think the other piece is just ensuring they can survive the environment. So the big one, things like corrosion, water ingress. I think we're pretty fanatical around water ingress and the level of testing we do to protect against that and how we do that. But yeah, look, I think it's what we have to strive for as vendors, because it's what utilities are demanding to keep the costs down and to make business cases.
Great. Any other questions from anyone in the crowd? I know we've got a few people on mute and videos off, so if you want to pop in.
Can you hear me there, John?
Yes, can hear you. Mark, nice to see you, mate. How are you?
No, good, John. Nice to see you.
Good. Long time no see.
Yeah. I guess question for Juan. Is this mostly a maintenance-based project, and how do you categorize the event? So if we take it as this is prevented, let's call it maybe a dry weather spill, which is quite a serious event, that's a KPI that would drive certain things to happen when that occurs. Because this is like a SCADA event, do they go in, clear the blockage, and then move on, and it's a win? Or is there like follow-up inspection to try and identify the root cause to prevent it happening again? Or is this a maintenance solution to, we got the alarm, we've cleaned it, it may happen again, but we're safe?
That's a very good question, Mark. I'm not 100% on how operations react to the alarms. From my perspective, I've been more focused on making sure the devices are fit for purpose and making the alarming at the right levels and surviving the environment, etc. But I'm not 100% sure how they react to the alarm and if there is a follow-up on the attendance of blockages to understand the root cause. Sadly, I'll have to park that question and go and investigate.
Thanks.
Sorry about that. I don't have an answer for you.
Any more before we wrap up, I guess?
There's one from Nathan.
Oh, Clement, lovely. There we go. Nathan,
Hey guys,
would you like to jump on? There we go. Yeah, nice. Cheers.
Yeah,
mate.
sorry for jumping in. Just a question, I guess, as we're seeing the upfront proportion of costs associated with these projects declining as affordability or as the capex cost reduces on the units. Just interested to hear from Southeast Water's perspective how you have learnt, I guess, from those embarking on their business cases for smart sewers at the moment, how you've gone about capturing some of these downstream operational costs, maintenance and so on in your business cases, and how you capture that with the uncertainty around some of the environmental considerations that we've just heard here and having to go and maintain and clean sensors after events and so on. Just keen to understand what you've learned from the process you've been through.
Yeah, that question is again outside of my realm of expertise in the company. It's definitely something that I know it's being considered within the smart sewer strategy that it's working at the moment as part of the digital transformation for the company. But I'm not aware on, like, I've been part of transmitting the learnings that will fit that business case, but I'm not aware how that input is actually transforming the business cases. That makes sense. So yeah, I don't have the answer. Like, I know what learnings are they. I know, for example, that having a replaceable battery is going to be beneficial for the business case, because then we can extend the device life of operation by a minimal cost of just having a quick maintenance call to replace the battery. But how that's going to impact the wider business case and the cost, for example, of the operational cost to have those maintenance calls, I'm not across.
Sure. Thank you.
Nathan, I might just jump in there too. I think it's a really good question. I think one of the trends that we're seeing, and that we've already seen a few utilities already go to tender with it, but a lot of utilities are now starting to move to a data as a service model, where they effectively push the maintenance costs back into the vendor ecosystem. So they say you're responsible for providing data for 5 years, and that includes the maintenance cost, or you're responsible for providing data for 10 years, and that includes the maintenance cost. And I think the reason we're seeing that trend is just a utility will be crystal balling, trying to understand what may or could go wrong, but also too there's just the risk appetite that, especially in these types of environments, if things do start going wrong, I mean, being able to draw that line really clearly to say, well, look, if it's your responsibility to give us the data, and you take responsibility of all of that downstream, what's your problem to fix? So yeah, I think it's a very interesting provocation, but I think that's how we've seen some utilities already respond to it through their operational models.
Perhaps I could also follow on the hostile corrosive environment and risk taking. You mentioned earlier on at the beginning, but briefly, about H2S. So I'd love to know a little bit more about that, because again, that is a problem, utility wide, especially if you've got interfacing with estuarine, briny, and sea areas with your infrastructure. How did you go about it, and what was it like trying to maintain them? Because they're pretty hard to maintain. So keen to get a bit of understanding and insight into that.
That's exactly what we learned. That's exactly what we learned. That's pretty hard to maintain.
All right. Okay. So of the data that you did get, though,
for starters, it's really hard. Yeah. For starters, it's really hard to select the right sensor that will integrate within your enclosure and survive the environment. But it's also calibration. It's also ensuring that the right amount of flow of air is going through the sensor, so you get an accurate reading. And that's what we learned from the data that we got, that our design was not really optimal for the airflow, so the sensor gave us an optimal reading. And yeah, that was it. It's a pretty good conclusion, I'll say, but it's probably one, and I didn't mention that on my presentation, but probably one of the things that I learned on all that process is try to keep your device to do one thing well, instead of trying to put multiple functionality into one device. I don't know if that makes sense, but
no,
we try to have a device. We try to have a device that was giving us level, it was giving us H2S levels, it was giving us flow, and the maintaining of those three things within one device was an engineering challenge. So I'll rather have one really good level sensor and nothing more.
Thank you so much for that.